Welcome surfers, it is Joel and this is Rustlers Atom 2.3. In today's video we talk about ownership in Rust. If you haven't subscribed to this channel yet, maybe this is the right time to do it to support the channel. In Rust, every value has an owner, but if I need to move constantly the ownership of a variable, coding becomes more or less impossible. To avoid all of this, it's possible to use a value without directly owning it. This practice is called borrowing. The first type of borrowing in Rust is the immutable reference. An immutable reference allows you to read data, but not to change it. You can create an immutable reference by adding an ampersand before the variable. Let's see. Now I create a string s1 equal to string from this. Okay. And now I can create a function to calculate the length of a string. Perfect. Let's close parentheses. Perfect. In this case, I take an immutable reference of a string with this ampersand symbol, and I return an uSides that represent the sides of the string. s.len. Okay, when the parentheses close here, s go out of scope, but nothing happens because calculate length function didn't own the data. Let's use this function. So let len equals to calculate length ampersand s1. Okay, and now I print both. I can print the string have a length of something. Okay, and s1 is still valid here because I don't move the ownership to calculate length, but I pass by an immutable reference. s1 and len. Okay, let's try this code. As you can see, I can print the string and I can also print the length. Perfect. Remember, you can have as many immutable references as you like simultaneously, but everyone can look it and nobody can mutate it. We can move to the second type of reference, the mutable reference. If you want a function to modify the borrowed value, you use a mutable reference, and to create a mutable reference you must write something like this. Mutable reference. Okay, ampersand mute. In this case is very important that the owner variable must also be declared as mute. So let's declare in this case a mutable string s2 equal to string from something like this. Okay. And now I can write a function that change the string, and in this case I need to pass a mutable reference of a string. This function don't have a return value because I don't need it. Okay, now s push str. I can push a string slice, in this case gslf can be a good example. Okay, this function modify my s string passed via a mutable reference. So now I can change my s2 string and I can print the result of this change. So changed string is something s2. Perfect. Let's compile this code. Okay, the changed string is this one. As you can see, my change function can modify s2 without owning it. Finally, we need to talk about dereferencing. Under the hood in Rust, references are pointers to a certain part of the memory. To access the data they point to, you technically need to dereference them. The dereference operation is made using the asterisk. Let's do an example here. Okay. Create a mutable x equal to 5. Create a y reference, mutable reference to x. Okay. And now if I want to use y to explicit change the integer value of x, I need an explicit dereference. So the value pointed by y is incremented by 1. And now I can print the value. The referenced value is equal to something. Okay. And now I can directly use x in this print line statement. Perfect. Let's try also this code. Okay, as you can see, using the dereferencing, I change directly the value pointed by my y pointer in this case. However, Rust has a feature called auto dereferencing and is used for method calls and for field access. For most dot methods like string.length, method like s.len on a string, or v.push on a vector. In all these cases, Rust handles the pointer logic for you automatically. But the only way to manipulate the actual value behind the pointer is the asterisk for the referencing. For this video, it's all. See you in the next atom, and don't forget to follow, to like, and to subscribe to this channel. Keep your thinking cap on. For this video, it's all. See you in the next atom, and don't forget to subscribe to the channel and to keep your thinking cap on.